Why do numbers exist? They are not objects we can pick up or touch. They are an invention, a way for humans to observe the physical world and record it. Artificial intelligence is the latest chapter in this history of observation. Before a machine can process anything, it needs data, and data is simply human measurement. When you step on a scale or check the temperature outside, you are turning a physical experience into a distinct value. This diagram shows how translation works. Person A is 160 centimeters tall, 55 kilograms. Person C is 200 centimeters and over 100 kilograms. Plotting these measurements on a 2D grid converts vague human descriptions like tall or light into exact numerical coordinates. A machine cannot comprehend a word like heavy. It can only read the coordinate. This translation from reality to measurement is the first quiet step in building machine intelligence. Measured numbers. Reality made measurable. Intelligence cannot exist in a vacuum. It requires this physical anchor. Measurement organizes the chaos of the world into a format a system can actually read. A single number provides a single fact, but when we measure multiple attributes at the same time, height and weight, or price and temperature, we begin to see relationships. Measured patterns. They are repeated structure hidden in reality. Knowing a static point is useful, but intelligence requires knowing where things are going. A system needs to understand the trend of a user's behavior or the intensity of a preference. That requires a vector, a direction in space. If a user prefers action films but dislikes romance, that preference is mapped as an arrow pointing toward a specific cluster of outcomes. Measured, a vector. It is a quantity with direction. By treating human habits and tastes as vectors, we stop simply collecting information and start mapping it. Machines can then calculate how similar two things are by measuring the geometric distance between their arrows. The world is uncertain. To navigate it, an intelligent system must be able to calculate the likelihood of different outcomes. This visual shows a normal distribution. It is the smooth, symmetrical bell curve that machines use to model reality. It reveals that even inside highly random data, clear, predictable shapes emerge. Measured probability. It is the mathematics of uncertainty. When a system encounters a new problem, it does not instantly know the answer. It calculates a probability, and it makes a guess. Often, that guess is wrong. This text outlines the core learning loop. A machine makes a prediction, measures the exact mathematical error, and adjusts. Like throwing a ball at a target. If you miss left, you adjust right. The system does the same with numbers. Measured learning, where mistakes are transformed into improvement. Artificial intelligence is the mathematical process of structured correction. It is the discipline of missing by a smaller margin every single time. A single loop is fine for a simple calculation, but identifying a specific human face or translating a novel requires scaling that logic up. This illustration shows how that happens through a transformation rule. The machine takes an input vector, like your viewing history, pushes it through a mathematical function, and outputs a predicted score for a new movie. Deep learning is the act of stacking these transformation rules on top of each other. In the first layer, the system detects simple edges. In the next, those edges combine into shapes. In the next, those shapes lock together into recognizable objects, measured layers. They are simple ideas stacked carefully. The complexity we see on the surface is an illusion. Underneath, the machine is applying the exact same basic math, passed meticulously from one layer to the next. A system processing millions of inputs at once is easily overwhelmed by noise. It needs a way to prioritize which pieces of data actually matter. We do this naturally. In a crowded room, you tune out the noise to focus entirely on the person speaking in front of you. For a machine, the mechanism that makes this importance visible is called attention. Importance becomes visible. This is vital for processing language. A word isolated on a page carries very little meaning. A machine must map how every word in a sentence relates to the words surrounding it. Transformers achieve this. Instead of reading left to right, a transformer evaluates every connection simultaneously, adjusting the weight of a word based entirely on its context. Transformers build understanding through relationships. Intelligence relies on finding the intricate web of context that turns scattered data into coherent meaning. Scaling data and power triggers a qualitative shift. Models solve novel problems as the volume of connections increases. With scaling, bigger changes everything. This graphic displays the entire sequence. We start with numbers and vectors. We move to matrices and probability. We end with optimization and learning. There is no magic inside the hardware. Artificial intelligence is built on the first principles of human curiosity, organized into mathematics. It operates as a bridge. On one side are the physical needs and observations of humans. On the other is the disciplined, structured logic of the machine, waiting to be directed.